this session. So later I'll give you a web video link so you can review, you know, if you miss something. Okay, first, let me see. This one. This one with actually I'll try to. I'm sorry. Let me see. How come this is so small? Okay, first this one. I think you don't when you are doing this, you have to do it step by step. Do it slowly, okay? Then you will get the correct answer. It's not really hard, right?
Yeah.
The whole thing is not really hard. I think you can do it, but you just need to be patient. Do it step by step. Treat yourself like a machine. Don't be smart and then try to jump somewhere. Okay, you cannot save state. So this is the result. This one actually, I put it down in black, and then this one blue. So this blue one is listed over here. Or I mean, I admit some one over here, so it's okay. I put a dot over there. Okay. So this one is the 402, and then I actually inverted. Okay, this is flip, and then this is 2's complement. So this is minus 402. Then minus 402 plus with 258. We got this, and then this number is the minus 144. This black one is minus 144. But I try to convert it to 2's complement. So with this, I see that the red one is 144. So this one in black is minus 144. So this is the answer. So 258 minus 402 will get, and that is minus 144. Okay. So I sent you this already. You can take a look on this. Okay. So now why I'm cleaning this. Okay. So why are we doing this code? Okay. Here we have the RGB code, right? So every time here, if I pick some color, say this one, right? I pick this one, this purple one. You see that? This purple one, when I move, the number hexadecimal here is moving. Say this one, let me pick one, okay? Let me pick this one. Okay, that's the number. Let me pick someone, okay? Say this one, right? This one got a number, this one is it's look at brown, but it's actually 401F1F, right? So I put it here, 401F1F. So the number is, they would write a punch sign, 401F1F. That actually means this. It's actually 00. I'm sorry, 0100 and 0000. This one is 404 and 0. Okay, this part is 0. This part is 4. So what is this number? This number is actually 1, 2, 4, 8, 16, 32, 64. So this one actually is 4. And then this one, 1F is what? It's actually 00011111, right? So this one is actually 31. And this one is also 31. So this one is red, this one is green, this one's blue. So let's go back. 64, 31, 31. That's your RGB code. So you need to be able to convert this real fast. If you want to design some program to be able to come up with color code. Okay, this is not only used in here. So if you try to build a website, ESS cascaded code. Okay, here are the color code as well. Right here, you have the same thing. Okay, this has the same thing. It has all kind of color code in here. Okay, here's a hexadecimal code right here, RGB. So it's a 2 half byte. Is 8 bit for a R, red color, and green and blue to combine with the color. So you need to be able to come up, and then here all kind of different color. So in the middle is a hexadecimal code. Right hand side is a decimal code. So if this one brown, you have FF equals 255, FB equals 248, and then this blue is 220 is actually DC, hexadecimal. Are you okay with this?
Maybe.
Yeah, what? Let me check. Okay, this one's recording. Okay, I make sure that you. So say this FF is 255, right? Let's look at it. Let's look at here. I'll clean this, okay? Since we have recording, I'll clean this. Say I have FF, right? So I have FF. FF is like hexadecimal. It's a 15, 15. So it's like 1, 1, 1, 1, 1, 1, 1, 1. And then you convert it into decimal. It should be 1. It should be 1 plus 2 plus 4 plus 8 plus 15 plus 32 plus 64 plus 128. And then this number, the whole thing, equals 255. And 255 actually is actually what? It's very, very rare. So if here say, let me try to this. If here I put in like 255, and then here 0, and then here 0, I'll get a red color, pure red color. But if I put in 255 here, 0 here, you will get
very yellow.
Very, I'm sorry. This is actually really green. I have not entered yet. Okay, so this FF in the middle is actually very green, right?
Oh.
If I want a yellow, it's actually red and the green. But remember, if you see right here, this is a hexadecimal code. The computer will read this, not this 255. Eventually, you need to convert it to here. Okay? So if I have a blue, I want to have a blue, pure blue. Here should be the 0. The second one should also be 0. The third one need to be 255. That's pure blue. Okay? And if I want to have all white, 30, that would be black. Okay? 3255, that would be FF. This one will be white. Okay, so this is called RGB color model. There are several different color models, and RGB is one of them. You have the RGB color model, EMYK model, SUV color model. So here are different color models. HSI, I'm sorry, I misspelled it, okay? There are several different color models, hue, saturation, and intensity, something like that. So here, these are different color models. I'm sorry, this one that I give you the explanation, but here, as you can see, here are several different color models. I can have a CMYK model. I have an RGB color model. I have this different color model in this color space. Okay, and to convert the color model into color space into your real world color, you need to have this RGB code. Okay, so I copy this for you, so later you can play around this color.
RGB.
RGB is red, green, and blue. Red, green, and blue. That's called RGB model. That's called RGB model. And then the other one, CMYK YK model is called cyan, magenta, and yellow. And the last one, B, is black. So two model, one is called RGB model, very popular. The other one is CMYK model. The third one is called HSI model. Three popular model. And then the RGB model is used for camera. Okay, RGB is for camera. Your JPEG file always using RGB model as for camera. And then CMYK model used for what? What this one is actually being used? It's used for printer. Okay? And then HSI used for projection, a lot of different applications. So these are something computer need to run, and this is overly done. Okay, even designing the website, these are basic knowledges. Okay, here you see we are trying to calculate different color model, and even in AP exam, there's some of the exam will test this as well. I have a review course, right? Let me bring up some problem for you. Actually, there is a let me see the diagnostics test. And then this one, let's look at the problem set. So this one, we have problem. Let me put this up. Sorry that it is not in here. Okay, I'm sorry. I probably picked the wrong file. But actually, this is already tested in like if you type Java. Sorry, my computer is real slow. Wait, it's not responding. Wait, let me close this one. Probably dead. Okay, so here has the Java RGB conversion. Okay, it's actually very common. If you check the website, it's always there. Everybody has this. This one is called color dialog. And then whenever you have a dialog, you have saturation, brightness, and alpha. Actually, these are the color model, the hue, saturation, and brightness. So sometimes the third one is different name. This one is different model called hue, saturation, and intensity. But this one called brightness. And someone use what? The U. U actually is different name. So hue or something. But actually, it has different name for this HSI or HSE model. But there are certain RGB model, CMYK model. So if you look at here, you type like CMYK model, it's also there. They are still CMYK. So that's why I said this one is used for printer. If you had a color printer, it actually always comes with this kind of ink, right? You're replacing the ink with the cyan, magenta, yellow, and black, 4 different tones, right? But in camera, if you look at the camera, it's actually, or television, it's actually RGB. So this different things actually used for heavily in application, real programs. It's actually very heavily used. And there's a certain study called color science and color scientist. They actually are doing this. No, this one is mega. I'm sorry, but color science is actually a special study. Color science is actually a special study. Like Khan Academy, they have a color science.
If I type a color sign in Java, would there appear a color?
They will teach you. Yeah, this good. So even color science is something that Khan Academy can teach. Okay, here has a lot of different things. Right, the one I use, like there's a name HSI and here is HSL, is luminance. So the last digit actually have different, and there's a RGB model. Here you can also learn the RGB model. Okay. Okay, three main kind of, yeah. Okay, so that's why we are using the RGB model, because our receptor is built to receive three different colors. Is that okay?
Mm.
Yes. Your computer is like this, or your TV is like this.
Mm.
Each one is 1 pixel. This is called 1 pixel.
Mm.
So each of the basic unit is called a pixel, Pixel. There's a company even called Pixar, right? Okay, some animal can have a lot of it.
Mm-hmm.
So because some animal they have more receptors, so some animal is able to see something people cannot see. Is that
Is
okay?
it only the color in the skin color?
What?
Is it
Can
the
you speak?
color that show in the skin color?
Can you repeat again? I do not understand it. Show in skin color?
Yeah, the color.
Actually, every color can be represented by this RGB.
Oh.
So for example, you have R as 255, green as 255, blue as 0, then you will get yellow.
Mm-hmm.
So three receptor just get different intensity on three different numbers.
Mm. Okay.
Okay, this is good enough. But here has a whole lesson for this, even a course for this RGB. But what is important is like in your camera RGB pixels in CMOS camera, it's called image sensor. So your eye is taking the picture for this, right? And then your computer, your digital camera, your whatever taking picture will have the RGB sensor. It is actually CCD or CMOS technology. It will actually take the picture. You have light on, and you actually will sense the data in the pixels. In the pixels, okay. And then here is the silicon will absorb the wavelengths of different colors in different zone, and then you will actually sense the different color for the camera. So that's the color for the camera. And also CYMYK is another color model for the printer. And both of them actually is like, it actually look like this. Let me clean this. So for example, if you have some certain color you want to do, actually it's just a color of some R value, some G value, some blue value. It will actually create that color for you. And how you actually mix up the color, actually, it's just like the model we get here. It's just like the model we get here. We can actually type any number, 67, and then this one, 81, and this one, 106. Okay, and then this is the color for with this combination. So all the combination of that actually is the whatever you can do with the RGB. It's called the color space. It's called the color space. So the color space is look like this. It actually look like this. Okay. But whatever RGB can do is actually within a certain triangle. Not all color can be represented by the RGB. So, for example, white gamma RGB is actually this triangle. You can only represent this color within the triangle. And CMYK, Japan standard, is actually a different color. But this, because it is very complicated, so it's only done by some color scientists. They can actually sense this and know which region you can do. Okay, is that okay? But basically, what I want to let you know is actually that number we are trying to do last 2-3 weeks actually is very powerful and very useful when you do the conversion for this color model. And a lot of things actually will be depending on this coding. Okay? Are you okay? So basically, you need to play around this, and you will understand. you know the perceptor for our eye or the our eye or the camera. Actually, when the light come, it actually has the light color frequency. Okay, it's some sort of frequency and wavelength, and then each color has its own frequency. Like this, it's like this visible spectrum. Okay, so certain wavelengths you actually represent different color. Okay, and that color actually can mainly be represented by RGB model, and then used for our coloring. So you asked me a question whether these RGB can be done by what? By our program. Yes, the answer is yes. The Java program can actually process in this. I probably told you before last time. Let me show you here. Let me pick up a program. Some of the program I did it before, right? Here I have a Java program, and here I have different color model. Color dark green, color pink, color dark this different color. So if you check the color table, here I have a Java code, and then if you type here, you say Java color gray, say. Okay, there's a color model. So Java different color actually defined over here. I'm sorry. This one don't show the value. Let me try another one. Let's try here. Okay, these are different color for color value for Java. So for example, this color white is 255, 255, 255. Color magenta is 255, 255. Color shine is actually 255, 255. Okay, so every color actually just follow this, and if I assign a number if I assign a number, if I assign a number from here, it's actually okay. Here in my program, I use color the red, right? But if this one actually I change it, I don't use color the red. I use a new color, and then I say 25500. This is the same as the color the red. So I compile, no problem, and then I run this program. Do you hear the music right now?
No.
No?
Yeah, I can hear any.
So here is the color.
Yeah, I can.
Hello? Can you hear it?
Yeah.
Okay. So I'm playing music and actually also playing the game. I show you this program before, right?
Yeah, I think.
I show you this program before, right?
Yes, I think.
But last time we actually use what? We use what? We use the Skype, but we don't get it, right? But here actually, if I change this, still accepted by Java. So we actually been able to do this later. Okay.
Okay.
Okay. Let me see. It's actually capital. And let me try this. So compile this. The red color, the red and new color, 25500. Actually, they are the same. Okay. But here I just want to show you like this binary conversion is actually quite useful. It's not something that useless. Okay. That's why I just try to teach you right now. Okay. Now let me clean this. Let's go back to today's topic. Have you taken the algebra 2 for trigonometry?
Can you give me an example?
No, I mean trigonometry. Actually, this one you have a unit circle, right?
Hey.
And then here we have an angle theta, right? And this one is cosine theta. This one called
No.
cosine theta.
No.
Have you learned this already?
No.
Sine cosine, you learned this already or not?
No, not very familiar.
And did you take it before? Okay, is this sine theta actually, for example, this is like C, this one's A, this one's B. Actually, is what? A over C. Have you taken this?
I learned something. I didn't learn very.
Briefly.
Yeah.
Okay, so what is sine's, say, 45 degree?
I don't remember.
So actually, you don't have background in here. Okay, that's fine. Okay, I will teach you some other time, but it is actually not a topic for today. Okay, I'm trying to see if you can take this one, but it probably need to be later. Okay, until you learn math about it. Because what? Because our chapter three. Our chapter three. Let me see. Our chapter three. Our chapter three is going to talk about Boolean variable. Let me see. And also some string. And then there's some math library as well. Let me see. It's Boolean. And then I'm going to teach you the math library, but that's fine. Okay, let me see. Let me bring up something else. Okay. Here is a mathematical model. So here's a math class. I originally want to teach you the sine, cosine, and in Java, but this one we have to skip right now. Okay. Now let me bring up a different module. Let me try to bring up another different module for you. Okay, one moment. Let me try this one. See, last time I did DBA modular student. This one student. Okay, this one student. The next one modular. Okay. Now let's do this module. I will rewrite it. Okay, I don't use this module. I put it here. Now let's look at the student module. Okay. We have a student and we want to know about its this guy's score. So now let's do this. We actually the first time we do system.out.print9 print with clean up the whole page. The next one, we want to write something, so we actually write system.out.print line, and then here we actually have a quote, say a few space, and then say, welcome to ABC High School System. Okay, and then system.out.print9. Enter your name. Okay, no, and then right here, I import java.util.scanner. And here I type scanner input equals new scanner system.in. Okay, and then we have a string name equals input.next line. Okay, so far let's stop here. Okay, so far I have a program, and then I print out this welcome to ABC High School System and enter your name. And then I set up a input string called input, and then I say input.next line assign the data to name. So let me run it. So here we have the welcome to high school ABC High School System, and the name, my name is enter, right? And the program start. So basically here I write a program with a banner, right? With a banner, and then I want to ask for a user to put in my name. So I create a scanner called input equals new scanner. That means what? That actually means that scanner class. That scan class is a collection of programs. So basically I have my keyboard here, right? My keyboard, right? And then here is a scanner in my program. So I keep typing like Eric and my name Chiao or something, and keep typing and pass through this scanner. The scanner I declare as input. The name is called input, right? And then when you say this scanner input, I'm trying to read something until I see a new line. So I'm trying to type Eric and space and Chow, and then last one I hit return. When I did return, here has a / n mark will be entered. Then I know, okay, this is one line. That's one line. So I put that one line into my program. So that's like, it's just like, let me see. Okay. So actually, this one system.input, set up this scanner, and then this next line actually will read the data until it hit a return. That return is called \n. And \n in our computer n in our computer actually is called right here. Let's actually look at it. It's called ASCII code. ASCII code, we talk about it, right? It's all the text being represented by ASCII code. So that one actually is called number 10 line feed. Give you a new line. Okay. That backslash n is line feed. Give you a new line. That backslash f, every time I put a backslash f, this backslash f, it actually is this number 12, the phone feed. It changed for a new page. So that actually is only one. This backslash f will be converted into this backslash f will be converted into this backslash in the computer. It should be converted into 0C for this backslash f. And then when we enter for here, this one actually capture a backslash and that's actually 0A for hexadecimal. Okay, that's the code actually got entered. But this actually, I type Eric Chow and then return, the whole thing will be read into the name. And the function I use is called next line. That means I'm reading the next line into my string is holding text. That function is called something like that. Let me clean this. Now, I'm going to continue to read more things. Now up to here. So I have my name already. The next one I have what? I should have my age. Okay, so I say my birthday, sorry. So I have a string birthday equals input that also input that next line. Here I should say, actually I should copy here. I just copy over. Now I change not your name, I change to birthday, right? And then the next one, I should continue to do something. Let me enter more. So I'm one more pair, two more pair. Here, I enter your math score. And this one say, enter your English score, right? And over here, this birthday, I don't like this. I put math score. And then here I put English score. So for Java, one thing to learn is actually when I try to create a variable math score, you don't write like this. You don't write math underline score. No, not like this. And you don't write like math and then space score. This is not. This actually is not okay. This one's okay, but not the traditional Java way of doing things. This is not particular. And also, you don't write capital math score. It's also not traditional Java way of doing things. But this is actually acceptable from computer point of view. Is okay. But this one with the space is not okay for the name. Now I have this. I have English score. I have math score. But my math. I'm sorry. I don't want to. I want to close it. But my math score shouldn't be a string. It's actually a text. I should be an integer, right? Or here, my English score should also be an integer. Now, what's wrong? I have actually next line. So I can't use the next line to read in integer. I should put next integer. So what happened is now I compile and then now I run my student class. So I enter my name again. I type in my name, and then my birthday 0102 1968. My math score 100. My English score 100. Something like that. Okay. So what happened is, back to my chart. I key in something. I use this one. This one use next line to read in a line for this, right? But if I key in this one 100, and then I actually use next capital I, lowercase nt, integer. I'm trying to read in integer. That's actually for integer number. But if I want to read in, say, 55.4, then I need to use next double. Remember, we use integer and double as the data format. So here, let's do this. Now I have this birthday, I have this math score, English score. So let me put double my chemistry, CHEM, score equals input that next double, right? And before that, I actually also need to print something, right? So here, I put in here, chemistry score, and then I compile. So okay, my name, my birthday, my math score, and then my chemistry score, I can type in some number, right? And this time it's actually enter in different system. It actually read in the data and assign to double. It's no longer integer, right? So let's print out the scores. Say if I want to print out scores, and then I put math score plus English score plus this one chemistry score. What would I get? I'll get, I'm sorry, English score. I should be lowercase. I'll get the sum of it. I'll get 150. And 150 actually is the sum of them. Sum of the three. And then original I have integer. And then this one I enter double. That actually is what? It actually the double type in real type. So this one, the end result it print now actually is a double type. It's a real number. It has a decimal value, decimal places up to the decimal point. So now, but I don't want to do this actually. I actually want to just print out my single subject score. I don't want to sum them together. So what I should do is put some extra space in between. So I need to put double quote, and the plus sign in between them. And then this time, let me print it out. Again, I put in my name, birthday, math score. Now, these three become separate. Okay? And when I plus them together, it becomes a mass. So what happened is, I have those three numbers. Okay, this one I will erase it. Right here, I have a system. That out the print line, and I put in math score plus English score plus chemistry. When I do this, actually it's sum together, so it become a total score 150 and got print now. Okay, and when I have math plus double quote, a space, English plus double quote, a space, plus chemistry. This one connect with this one first, so it become a string called 50 space. And then connected with English score, that's another 50 and space. And then finally, I got a 50.0, so it's a 50.0 got printed. So eventually, what I print now, it becomes 50 space, and then 50.0. Because when this plus is a concatenation, it actually hook up the whole thing, the mass score and the space, become a text. But right here, it doesn't connect the space with the M and English and actually it doesn't connect these three. It actually, the plus sign means plus, so you get 150. That's the result, the difference, but over here. Is that okay so far? Hello? 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 Do you hear me?
Yep.
Is that okay?
Maybe.
Why? Can you repeat what I just say? What does this mean? And that one mean, the lower one means in my program. Do you actually really understand this or no?
No, not really.
Okay. The first one, I actually put it here. I don't have a space in between, right? So it's just like normal math. So it's something together and then print out, right? That's no problem, right? But if I have, say, let me delete this chemistry. Just math score and English score. And in the middle, I put in double quote. That is actually a character, a string, some text in there. So I have a math plus some text. It will become no longer a number. It become a text message. So that actually is 50 and the space. And then I add another English score. That actually is actually connecting together. That plus is not really a plus. It actually is a connecting things. So this one, the number English, actually is the number English, it will actually be 50. And then the mass is also 50, but it becomes 50 quote. Because this one is the quote string type. So that 3 will become 50, and then a space, and then 50. That connected together as a big message. But if I don't have a double quote in between, the English number and the math number will be summed together. Is that okay? And then here I put the chemistry in as well. Then it will become, chemistry is a real number, so it will be 50.0. So it's like mass is 50, and then connected with a text of space. So that become a bigger text called 50 and space. And then connected with another 50 and space. And then connected with 50.0. So it becomes something like this. So here, if I do this, if I do this one, English and math, no space, and then plus space with chemistry score. This one should get 100 and then space with 50 0. So if this one is the case, it becomes 150 100 space and 50 dot 0. Because what? Because my math and English, when they connecting together, they are not connecting by the dual of text with number. It's by the dual of number with number. So it's actually 50 plus 50. When number plus number, that is a number. So it's a 100. But a number plus a text, it will become a text. So here, if I don't put this space, I put SSSS. Here I have array 0, 1, 0, 2, 0, 1, 0, 1, 50, 50, 50. It becomes 100 connecting with the text SSS in between. Is that okay? Are you okay with this? Yeah. So here we are dealing with some printing problem. Okay, we are dealing with some printing problem. Now you get the 3 score in, right? So we actually can do this. We can do a real number and then average, right? And then I have math score plus English score plus chemistry score. And then I want to divide it by 3. Okay. Okay. Right here, if my chemistry score is also an integer, right? And I write down something like this. Okay, I write down math by English plus chemistry divided by 3. And then right here, I don't print this anymore. So I say average column space plus, and then average. So normally we put a plus here means what? Means I have an average column and then space, and then I connect it with a number called average. So you should print out a new message with the average and then the number. Is that okay? Hello?
Yep.
Okay, what will be the result here?
The result for that will be the math scored averaged. The average for math score is 50.
Will be what?
25.
I have a typo. It should be average. Okay.
25.
What will be the result? It will be printed out here.
So the average for 3 will be 50 divided by 3. No, 100 divided by 3.
Say right here, if I have this this one, I have 50, 50, 50. So what result should I get?
50.
It's not 50.
Eh?
Okay, what's wrong with the program I have here?
What's wrong?
What's wrong with this? Because the chemistry divided by 3 first. That will become 16 something. So what you need to do is actually be careful. You need to do this.
Oh, okay.
Right?
Yep.
Then you will get the right answer. Otherwise, it will be wrong. Okay, one thing, the first thing you need to be careful is this. Okay, I type in a lot of 50. It's okay. It says you got an average. Now, another problem, actually, let me wrong again. I have this 150 type in, it doesn't matter. Okay, it's just a text. So now I have 6, 6, 5. What should I get? If I have 65, what would I get? What should I get?
Divided by how many?
Divided by 3. 6
All
plus 6 plus all of them, yeah. 65, what is the average?
Average will be 6.
6 plus 6 plus 5 divided by 3, what would be the average?
Will be 3/17.
So what's the number?
3/17 is
17 over 3, yeah.
yeah, 17 over 3.
It should be 5 point something.
Yeah.
But the answer is 5.0. Why?
Because you say we have to go to the 1 decimal place.
What?
Because you state that you don't have to go to any decimal places.
That's because it round off, right? Round off the nearest integer. But why this one will round off? Okay, but here if I put not put 3, I put a 3.0. If I put a 3.0, what would happen?
It will be 1 decimal places.
Why?
Because this is 2 compound number.
Why this one is 5.66, but the one without is 5. This one is this, and why that one? Why that one actually? I have this, and then 6, 6, and 5. Why this one got 5.0, but the other one with 3.0, you actually got 5.667. Why?
Because 3 is 1, no decimal, and 3.0 have 1 decimal.
That's not the answer. That's not the answer. And then how about this? How about this? I don't write this. I write a bunch of 0 there. So should I get several as many as I should get?
我一直都没下课，一直叫什么叫啊？
Okay, if here I have this, right? And then I have 5, 5, and then 6. Actually, it doesn't matter how many digits it is. The problem is not the number of the digit. It doesn't come from the number of the digit. Is it because okay, is it because I have a math score that is a integer? I have an English score that's also an integer. I have another chemistry score that is another integer. And then I divide by 3, that is yet another integer. So this whole thing sum together, that is the integer. So integer divided by integer, this one is called integer division. Okay. So what happened for integer division is, I'll clean this, okay? Say, if I have a, integer a equals 17. I have a integer b equals 3, right? That's the example I gave, right? So now I have a divided by b, right? And then I give it to a certain integer, or even double. Let me put it double. And then I give it to q, some q value, right? This one 17 divided by 3, I got 5. Not 5.66. No, because it's called integer division. Okay, so the double type I receive here is I divided by 8, so I got 5, and then you convert it to double, it becomes 5.0. So it's an integer division, but after that I convert this back to double because the left hand side need a double. Is that okay?
So if you put a decimal over there, it will not.
Now let's now let's look at the other case. The other case, I have an integer a equals 17. I have an integer b equals 3. And I don't use this one. I have a double c equals 3.0. Now I have another double. This one q again. A divided by c. This one is 17. This one is 3.0. As long as one of it is a double type, a real number type, it will get 5.6666 whatever, and then assign the double value to here. So the right hand side become a double and then assign to a double value. The previous one we used b, that's a integer. So integer divided by integer becomes a integer. So you will just round off to 5. Is that okay?
So if you put double, it will be more decimals. If you put integer, will be like in division, so will be only.
Yeah. Okay, now let's look at one example here, modulus. Okay, I have a 17, I have a 3, so I got the integer q equals a divided by b, and r equals a modular by b. Let me round it. Okay, let me round it.
What is modular?
Modular is the remainder. I'll show you, okay? So this one is what I get. Now let's go back to the whiteboard. Okay, I clean this. So right here, I have 17. That's actually my A. Divided by 3, that's my B. And then I got 5, that's my Q. 5, and then 15, that's remainder 2. This is the R. Right? So look at our code. Our code right here. A divided by B is like 17 divided by 3, right? I got a Q. So Q here I got, it's actually as this 5. And then the R is actually the remainder. The R is the remainder. So when I say A take modular by B, is getting the remainder. Is that okay? It's getting the remainder. So say right now I have 5 modular by 3. It's actually 2. 5 divided by 3 is the remainder is 2. Here I have 100 take modular by 7. What's that? I have 100 take modular by 7. 1, 7, 30, 4, 28. I got 2. Here is again 2. Okay? So this is the remainder. Modular is the remainder. Okay, modular is the remainder. So let me try to give you the idea. This one is how to use it. I'm modular. Second one. This one is not good. Okay, this one tutorial. Okay, so here teach you how to use that modulus. Okay, I copy this one. You should spend some time to read it. Okay. That's the modulus. So this one, I have 17 divided by 3. I got 5, and then remainder 2. That's the value I have. And then I have to recover the data. B times Q plus R. What does that mean? That actually means my A divided by B is Q remainder R.
Hello?
Hello? Do you hear me? Hello? Do you hear me?
Wait, why I cannot hear anything?
Hello? Do you hear me?
Yep.
Okay. So this one actually is A times B. I'm sorry. B times Q plus R should be A. It should be equal to A. That's the recovered A. So the recovered A should be the same as A, because A divided by B equals Q. A divided by Q equals B. A modular by B actually equals R. So B times Q plus R is the A, the same as A. That's the rule for integer division. Is that okay so far?
Yeah.
Okay. So you need to run for your course. So up to here, maybe okay. Let me teach you one more thing. The leap year. So this one is actually quite simple. So here I have this. I try to decide whether a year is a leap year or not. So I have a year. I come in. I have a year, and a year divided by 4. Okay, is A. Year divided by 100, actually 10 modular by 100 not equal 0 is B. And then this means take year 10 modular by 4 is 0. The double equal sign means equal. So if the year divided by 4 equals 0, then means that the year is a multiple of 4. And then this one's C, year is multiple of 400. And this one, B, year modular by 100 is not 0, means that year is not multiple of 100. So a leap year is decided by, if the year is the multiple of 400, then it's a leap year. Or if the year is not a multiple of 100 and it is a multiple of 4, then that year is a leap year. So I started from 1990 to 220, and every 2 years I print it. Now that means don't do every year, that means do every year. Okay, let me increase by every year and then run it. Okay, here is a table. Here's the table from 1990 to 2020. 1990 is not a leap year. 91 no, 92 yes, 93 no, 4 no, 5 no, 6, 96 yes. So this leap year are the year we have the Olympic game, right? So it's something like that. You check every 4 years there's a leap. But say if I try 1900, it will be false. Something like that. So modular is quite useful in many applications. Here show you the modular's application. One of the application is to calculate the leap year. Is that okay? So today I teach you basically the integer division. I teach you the integer division, and also I will give you these 2 programs, the leap year, modulus, and student. Your version and the other version I'll give you. And then I'm going to assign you some problem about this modulus. Is that okay? Hello?
Okay.
Yeah. So you need to run for another class, right? So today is up to here. Thank you. Okay, bye-bye. I'm going to send you the homework later, okay? Maybe 1 hour, 2 hours later, okay? Thank you. Bye.
Thank you.